All right, ladies and gentlemen. So, a polynomial function is a function of the form f of x is equal to a sub n times x raised to the nth power plus a sub n minus 1 times x raised to n minus 1 power plus dot 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 plus a sub 1 x plus a sub 0, where a sub n cannot equal 0. Where a sub n is the leading coefficient and the exponents are whole numbers. N is equal to the degree. Coefficients are real numbers. You got to remember the difference between whole numbers and real numbers. And a sub 0 is the constant term. It is in standard form when its terms are written in descending order of exponents from left to right. So example 1, decide whether the function is a polynomial function. If so, write it in standard form and state its degree, type, and leading coefficient. So a sub 1 has f of x is equal to negative 4x to the fifth plus 7x squared minus 2. So remember, if it's a polynomial function, it has to have certain things. Well, if we look at our exponents, they are whole numbers. Remember, whole numbers are anything but 0, but they can't be decimals, etc., etc. So it's a whole number. All right. So on that one, that it works. All right. And remember, a whole number is positives. So on this one here, we're okay. So it is a polynomial function. Okay. You look if it's in standard form. Are the exponents decreasing in order from left to right? In this case, it is. So you would tell me it is in standard form. Okay. On this one here, the degree is 5. All right. We only have special ones up to 4, and I'll tell you that one on the next one. All right. And its leading coefficient, remember the coefficient is the number in front of the variable. In this case, it is negative 4. There's our 5. It is in standard form. All right, second one. Again, what we have to do is look and see, are the exponents whole numbers, which they are. All right. So it is a polynomial function. Okay. Now on this one here, if you look, it is not in standard form. So we have to put it in standard form. Our highest one is the 4th power. So we have to rewrite it. So we're going to write g of x is equal to the cubed root of 3, x to the 4th, plus 5/10 x squared plus 19. Okay. Its degree is 4. All right. So on that one there, if we have, say, a type, okay, well, we know 3 is cubic, we know 2 is squared, we know that x to the first power is linear. The 4th one's the only other one that we need to know. So its type, and it's called quartic. Okay, it's called quartic. And in this case, your leading coefficient. And I did put that short because I'm running out of room, and that would be the square root of 3. Let's see, number for C, we have -4 right there. Is that a whole number? No, it's a negative number. So we would say not a polynomial function. Okay, it is a function, but it's just not a polynomial function. All right, and your reason is -4x to the -4th. I just told you that right there. Has an exponent. That is not a whole number. Okay, and finally for D, our last one here. Let's see, k of x is equal to x squared plus 9 raised to the x power minus 1. Right there, that should also tell you, ladies and gentlemen, it's not a polynomial function. Because for our 9 raised to the x power, x is not a whole number. Okay, so evaluate means just plugging in. So it says evaluate f of x is equal to -2x to the 4th plus 6x cubed minus 3x plus 11 when x is equal to 4. So again, they're saying x is equal to 4. So I'm going to, wherever I see x, I'm replacing it with 4. Remember what I told you, every single time I see a variable I'm replacing, put it in parentheses. Because that's going to tell us we have 4 to the 4th power plus 6 times 4 to the cubed power minus 3 times 4 plus 11. That gives -2 times 4 squared. 4 raised to the 4th power is 256. 4 cubed is 64. And we'll have minus 12 plus 11. -2 times 256 is -512. I'm sure a lot of you would have just plugged this into your calculator right now. And now I would have gotten -129. All right. Now, end behavior is going to be something important. We're going to see more about it tomorrow. But the end behavior of a function's graph is the behavior of the graph as x approaches positive infinity. So as x goes to, okay, that arrow means it goes to infinity or negative infinity. Again, in parentheses, I have there x goes to, the arrow means goes to. Negative infinity is determined by the function's degree and by the sign of its leading coefficient. So when the degree is odd, you know what an odd number is, 1, 3, 5, 7, 9, etc., etc. All right. We know that when the leading coefficient is positive, we know that we're going to have something that looks like this. We know that It's going to have something like this, and it's going to have something like this. And then somewhere along the line there, ladies and gentlemen, we're going to have a function. So I'm just going to kind of draw a quick one here for you. We know we're going to have something that looks like all right, so that would be an odd function. So if we look at that, what we can say is, remember, this is our y-axis, this is our x. So as x goes to positive infinity here, what does f of x, or your y value, go to? F of x is also going to positive infinity. If we look on this side here, as x goes to negative infinity, remember, we're going this way. X is going this way. So we're going to negative infinity. F of x, which is our y value, is going down, and it's approaching negative infinity also. That's when it's odd and the leading coefficient is positive. When the leading coefficient is negative, and again, I didn't give myself enough room, so that's why I'm going to put stuff like that. So on this one here, this is again my y-axis, this here is my x-axis, and I know on this time here, I'm going to have it going like this. All right. And again, I'm just going to draw a function here. And on this one here, what can you tell me? And I'll put purple here since I don't want to have it confused here. So as x goes to negative infinity, f of x is going to positive infinity. And over here, as x goes to infinity, what is f of x doing? F of x is going down, so it's going to negative infinity. And let me make that infinity. All right, so that's when they're opposites. So they're either going like this or they're going like this, almost like a robot kind of thing. All right, when it's even, they're both going to go up or they're both going to go down. All right, so when we're talking about even and our leading coefficient is positive. So on this one here, I had to make sure I had enough room here. Again, this is my y, this is my x. And we'll see that on both of these ones here. Sorry. Just want to make sure they were still in red. So I'm going to have it go up like this when it's positive. All right. So if we look at that, what am I telling you? So as x goes to negative infinity, f of x is going to positive infinity. So that's negative infinity on that top one. I hope you see that. And on this one here, as x goes to positive infinity, f of x is going to positive infinity. And I'll draw like I said, I'll draw, remember, will this be almost like a parabola? So, but I'm going to give you a different one. I'm going to give you a quartic. And if you look, a quartic looks almost like a W. All right, and then let's do our leading coefficient as negative. And when my leading coefficient is negative, all right, and on this case here, since when it was positive, they both went up, when it's negative, they're both going to go down. All right, so here's my x, here's my y. I'll change the color to purple again just because I didn't last time. So in this case, as x goes to negative infinity, remember that means I'm starting here and I'm going this way. I'm going negative. All right, and then f of x, all right, f of x is going to negative infinity. That means it's going this way no matter what, okay? Oops, sorry. And then as x goes to positive infinity, we can see that f of x, when the leading coefficient is negative, will still go to negative infinity. Again, think of it as both up or both down. And again, here I'll make you a quick quartic here. All right, so our last example for today. Describe the end behavior of the graph. F of x is equal to negative 3/10 x cubed plus 1.7 x squared minus 4x plus 6. So if it's not in standard form, put it in standard form. This one is in standard form. So again, the leading degree tells us if it's going to be odd or even. So if we look here, we have our degree. It is odd. Okay. Our leading coefficient, and that's why we have to put it in standard form, people. And our leading coefficient here, you can tell me it's negative. All right. So which of the top four that I just drew here does it look like? All right. So its degree is odd and leading coefficient is negative. So that means it's this one here, right? So you will just tell me as x goes to negative infinity, f of x goes to positive infinity. And as x goes to positive infinity, f of x goes to negative infinity. Be careful, because when you're doing what you have to on big ideas, my guess is they're going to have you drag and drop. All right. So be careful on it, and you should be able to do the homework there. All right. Sorry about that. I guess I didn't. Bye.